Hey there, and welcome to this deep dive. Really glad you could join us today.
Yeah, good to be here.
We are jumping into something pretty transformative, I think, for how we learn.
Definitely.
We're talking about how AI is creating these incredible immersive learning environments.
It sounds like sci-fi, but it's really happening now.
Exactly. This isn't some far-off future thing. It's technology that's, here, reshaping classrooms, training, how we even interact with knowledge.
Mm-hmm.
So today's deep dive is centered around exploring a key document. It's called How AI is Creating Immersive Learning Environments.
Right.
And our goal is, basically, to unpack that source for you. We want to pull out the key insights, help you really understand what this shift means.
It's about how AI, especially when you mix it with VR and AR, virtual and augmented reality, is moving us away from just like passively watching.
And actually doing.
Yeah.
Actively participating in the learning.
Exactly. And that feels especially relevant for places like, say, Canada, right?
Yeah.
With a strong tech sector, but also those geographic distances.
Yeah, bridging those gaps, potentially.
Hmm.
So to kind of set the scene, think back to how most of us learned certain things.
Textbooks, diagrams,
Yeah.
maybe a lecture.
Right. All useful, sure. But sometimes there's a bit of a disconnect, isn't there? You read about, I don't know, a complicated engine.
Or the human circulatory system.
Yeah. You see the picture, but really getting it, feeling how it works,
Yeah.
that's different.
It really is. It's the difference between, say, reading about the heart and actually putting on a headset and stepping inside a virtual beating heart to see the valves work.
Oh, okay. That's a powerful image.
And that's the kind of shift we're talking about, from knowing what it is to understanding how it works because you're essentially doing it.
Okay. So that fundamental shift, that move from passive to active, that's where we should start.
I think so. That's really the core transformation the source emphasizes. Traditional methods, they often relied heavily on memorization.
Right. You cram for the test, maybe you remember the facts for a bit.
But applying them, or truly understanding the why behind them, that could be harder.
So what's the alternative that this immersive approach offers?
It's all about experiential learning. That's the key phrase. It's about getting you, the learner, right in the middle of it.
Engaging more senses.
Engaging multiple senses, yeah. Requiring you to solve problems within a context, not just abstractly. Linking the concept to a practical action.
So like you said, not just seeing the diagram of an electrical circuit, but maybe virtually building one.
Building it, testing it, seeing what happens if you change a component, all in that virtual space.
And there's evidence this actually works better.
Oh, definitely. The source mentions, and it's well established, decades of research support learning by doing. It's not just a nice idea.
Okay.
Studies consistently show it leads to significantly better long-term memory, better retention, and a much deeper understanding compared to just, reading or listening passively.
It just makes sense intuitively.
Yeah.
You remember doing something far more vividly.
Absolutely. And the technologies that really make this digital doing possible are VR and AR.
Right. Virtual reality and augmented reality.
But even those initially had limitations. They needed something else to really make them dynamic learning tools, not just fancy slideshows.
Okay, so let's break those down. How do VR and AR actually
Yeah.
create these spaces? And then where does AI fit in to, supercharge them?
Good question. So let's start with virtual reality VR. Think of it as total immersion.
Okay.
You put on a headset, maybe hold some controllers, and boom, the real world around you is blocked out. You are completely inside a computer-generated environment.
Like stepping into another world.
Exactly. The source gives examples like, suddenly you're standing on the surface of Mars. Or you've shrunk down and you're exploring inside a human cell.
Wow.
Or maybe you're witnessing a key historical event like you're actually there. You are in that simulated reality.
Got it. So VR completely replaces your surroundings. What about augmented reality, AR?
AR is different. It doesn't block out your real world. Instead, it overlays digital information onto your view of reality.
How does that work?
Through a phone. Often through a phone or a tablet camera, yeah. Or sometimes specialized smart glasses. It layers things like 3D models, text explanations, maybe animations onto what you're actually seeing.
So if I were, say, learning to fix a specific machine,
AR could potentially overlay interactive labels onto the real machine parts right in front of you, or show animated step-by-step instructions directly on the equipment.
okay, that's pretty cool. Or like those apps where you can place virtual furniture in your room.
That's a perfect consumer example. Or putting a virtual T-Rex in your classroom, AR augments, adds to your existing reality.
Okay, clear distinction. VR, you're in a new world. AR digital stuff is on your current world.
You got it.
But the source document says AI is the real game changer here. The power-up, they call it. Why? What does AI add that VR and AR alone don't have?
This is the crucial point. Without AI, VR and AR experiences, while visually impressive, can be quite static.
Like a 360-degree video or
Yeah.
a pre-programmed tour.
Exactly. You can look around, maybe click on a few things, but the environment doesn't fundamentally react or adapt to you in an intelligent way. It's pre-scripted.
Got it.
AI is what makes these immersive environments dynamic, responsive, and truly intelligent learning ecosystems. It turns a passive viewing into an active interaction.
So how? What is the AI actually doing behind the scenes?
The source highlights several key mechanisms AI enables. First, there's dynamic content generation.
Meaning?
Meaning, instead of exploring a single pre-built virtual lab with maybe 5 fixed experiments, the AI can generate countless variations on the fly.
So it creates new scenarios as you go.
Potentially, yes. Imagine a virtual chemistry lab where the AI can set up unique experimental conditions based on what you've done before or present unexpected results to challenge you. It's not just replaying the same thing.
That encourages real exploration, not just following staffs.
Precisely. It fosters genuine scientific inquiry, for example. Another huge role for AI is powering intelligent and responsive characters.
NPCs, like in video games.
Sort of, but potentially much more sophisticated for learning. These aren't just figures standing around. AI allows them to engage in natural language conversations, react realistically, and embody specific knowledge or personalities.
Can you give an example?
Sure. Think about a history simulation. Instead of just reading text about, say, Julius Caesar, you could potentially talk to an AI representation of Caesar who draws on historical data to respond to your questions in character.
Whoa. Interesting.
Or imagine a medical student practicing patient interviews. The AI-driven virtual patient could have symptoms that evolve dynamically based on the student's questions and diagnostic choices. It's not a fixed script.
That sounds incredibly valuable for training much closer to the complexity of real life.
It really is. And that ties into the next AI capability, personalized and adaptive simulations.
Adapting to the learner.
Exactly. The AI can observe how you are doing within the simulation in real time. Are you struggling with a concept? It might simplify the scenario, offer subtle hints, or highlight key variables you're missing.
And if you're getting it easily?
It can ramp up the complexity, introduce new challenges, maybe unexpected curveballs, to really test your understanding and application. It tailors the experience.
Like having a personal tutor adjusting the difficulty level constantly.
That's a great analogy. It adapts to your individual learning pace and needs. And finally, AI enables really sophisticated real-time assessment and feedback.
So not just a score at the end.
No, much more than that. The system isn't just waiting for a final answer. It's analyzing your process, the actions you take, the decisions you make, how you approach the problem within the simulation.
And it tells you right away.
It can provide immediate contextual feedback. Imagine you're learning virtual welding. The AI might say, notice how changing your torch angle right there affected the bead quality. Or in a medical sim, why did you opt for that diagnostic test before considering X?
That's powerful. It's assessing the how, not just the what. Evaluating the practical skill as you're doing it.
Which is a massive shift from, say, a multiple choice test about welding theory. This assesses applied competence.
Okay, so these AI capabilities, dynamic content, smart characters, personalization, real-time feedback, they sound like they could be used almost anywhere.
They really unlock potential across the board.
Let's explore some of those applications then.
Yeah.
Where is this tech actually making a difference or showing promise? Maybe start with something like history or social studies.
Oh, definitely. The source talks about virtual time travel. Imagine, instead of just reading about ancient Athens,
You can walk through a reconstruction of the Agora.
exactly, see the Parthenon up close, maybe interact with AI characters representing figures like Socrates or Pericles based on historical texts, or explore a virtual reconstruction of an archaeological dig, seeing artifacts in situ.
That makes history feel so much more alive than just dates and names.
Completely. It leverages that spatial, experiential memory, and related to that is cultural immersion.
How so?
You could virtually visit landmarks around the world without leaving the classroom. Maybe experience a simulation of daily life in a different culture, interacting with AI characters to understand customs, perspectives, maybe even practice basic language phrases.
Breaking down geographical barriers to understanding the world, that's huge.
It really is. Now, think about STEM fields, science, tech, engineering, math. This seems like a natural home for immersive learning.
Yeah, I can see that. How's it being used?
It's pretty revolutionary here. One big area is creating safe and scalable virtual labs.
Safe because.
Because you can conduct experiments that would be too dangerous, too expensive, or require materials unavailable in a typical school lab. Think mixing volatile chemicals, working with high-voltage circuits, or even complex genetic manipulation simulations.
Right. No risk of actual explosions or ethical dilemmas with virtual fruit flies.
Exactly. Zero physical risk. And scalable because you're not limited by the number of physical lab stations or the cost of consumables. Students can repeat experiments as many times as needed to master the concepts.
Unlimited retries without breaking the bank.
That's a huge advantage. Another key STEM application is visualizing the abstract or unseen.
Things that are hard to picture.
Things that are really hard to picture, like truly grasping the scale of the solar system by virtually flying through it, or shrinking down to molecular level to see how DNA replicates, or walking around inside a complex 3D mathematical function to intuitively understand its shape and behavior.
Making the invisible visible. Wow. They could change how students connect with science and math.
It has the potential to make those abstract concepts suddenly click, to create more of those aha moments.
Okay, so history, STEM. What about more hands-on skills,
Right.
like trades or healthcare? You mentioned Canada earlier.
Yes, this is a massive area, especially relevant for economies needing skilled trades and healthcare professionals. The potential for vocational and skills training is enormous.
Like what specifically?
Take medical and surgical training. Students can practice complex procedures, surgery, diagnostics, emergency response on incredibly realistic virtual patients.
Driven by AI.
Driven by AI that can simulate different patient anatomies, unexpected complications during a procedure, varied responses to treatments, and importantly, the AI provides detailed, objective feedback on their technique, their precision, their decision-making under simulated pressure.
Practicing high-stakes skills safely before touching a real patient. That's invaluable.
Game-changing for developing both competence and confidence. Then there's technical and trades training.
Like construction or manufacturing.
Exactly. Imagine learning to operate complex, expensive, heavy machinery like an excavator or a crane in a realistic simulation first. Mastering the controls, understanding safety protocols, all before getting into the real multi-million-dollar equipment.
Reduces training costs and risks significantly.
Hugely. Or using augmented reality, remember the overlay idea? An AR headset could guide a mechanic through a complex engine repair step by step, highlighting the parts, showing the procedure right on the real object.
Learning the muscle memory and the process in a safe, guided way.
You got it. And it's not just hard skills. The source mentions soft skills development, too.
Really? How does that work?
Think about practicing public speaking. You could stand in front of a virtual audience whose reactions, engagement, boredom, questioning looks are driven by AI based on your delivery.
Wow, okay. Facing your fear in a safe space.
Or practicing difficult conversations. Imagine role-playing a negotiation or a sensitive feedback session with an AI character programmed to have a specific personality or objective. You can practice different approaches and get AI feedback on your communication effectiveness.
That's a really interesting application. I hadn't thought of using this tech for interpersonal skills.
It shows the breadth of possibilities.
Okay, so when you pull all these applications together, history, STEM, medical, trades, even soft skills,
Yeah.
what are the big overarching benefits this AI-driven immersive approach offers, according to the source?
Well, several key benefits really stand out. First, and maybe most obviously, is deepened engagement and motivation.
Because it's more fun.
Partly, yeah. It's often more interactive, hands-on, sometimes feels like exploration or even a game. For many learners, it's just inherently more captivating than passively absorbing information.
And does that engagement lead to better learning?
That's the second major benefit, enhanced knowledge retention. We keep coming back to it, learning by doing, using multiple senses, actively solving problems in context. That just embeds knowledge more deeply. You remember it better and understand it more thoroughly.
Makes sense.
What else? The safe exploration and failure aspect is huge. In the real world, mistakes can be costly, dangerous, or embarrassing. In these virtual environments, you can try things out, experiment, mess up, and learn from it without any real-world negative consequences.
That must build confidence.
Absolutely. It creates a psychologically safe space to take risks, which is crucial for learning complex skills. It also really helps bridge the gap between theory and practice.
How so?
You're not just learning the what from a book, you're immediately applying the how in a simulated functional context. It connects the abstract knowledge directly to practical application. Less, okay, I read about it, now what?
Exactly. And finally, maybe one of the most profound benefits, especially thinking globally or across large countries like Canada, is expanding access to experience.
Making things available that weren't before.
Precisely. This technology has the potential to democratize access to learning experiences that are normally limited by cost, geography, or safety concerns.
Give me an example.
Think of a student in a remote northern community in Canada, physically traveling to, say, the Amazon rainforest or the International Space Station, or even a state-of-the-art urban medical facility might be impossible.
Right, completely out of reach.
But with high-quality immersive learning, they could potentially have those experiences virtually. Walk through a simulated rainforest, float through the ISS, observe a complex surgery, experiences that profoundly enrich learning but were previously inaccessible.
So it's not just making learning better, it's potentially making incredible learning available to far more people.
That's the real promise here, the potential for leveling the playing field in some ways. Okay, that potential is massive. But realistically, getting there, it can't be easy. There must be challenges, hurdles to actually adopting this widely.
Oh, absolutely. The source is clear about that. Widespread adoption faces some significant practical and ethical obstacles.
Let's talk practical first. What are the big blockers?
Number one is probably hardware cost and accessibility. Good VR headsets, the powerful computers needed to run these complex, graphically rich simulations. They're still pretty expensive.
So the digital divide issue. Not every school or student can afford this tech.
Exactly. Ensuring equitable access, making sure this doesn't just benefit well-funded institutions, is a major challenge that needs solving.
What else on the practical side?
Creating the actual experiences, high-quality content creation is a huge bottleneck.
It sounds complicated.
It's incredibly complex and resource-intensive. Think about it. You need subject matter experts who know the content deeply. You need talented instructional designers who know how people learn. You need skilled 3D artists and programmers to build the virtual world. And you need AI developers to make it dynamic and intelligent.
That's a lot of different expertise needed for just one learning module.
It really is. Building a library of rich, effective, AI-powered immersive content takes significant time, money, and collaboration.
Okay, cost and content creation. Anything else?
Yes. Even if you have the headsets and the software, you need people who know how to use it effectively in an educational setting. So teacher training is critical.
Getting educators comfortable with it.
Comfortable and proficient. They need support, professional development, guidance on how to integrate this into their curriculum, how to manage a classroom where students might be in VR, and how to interpret and use the performance data these systems generate. You can't just drop the tech in a classroom and expect magic.
Right. So hardware access, content development, teacher support, those are big practical hurdles. What about the more human or ethical side of things?
The source brings up several important points here, too. One is potential health and usability issues.
Like getting dizzy.
Yeah, some people experience cyber sickness, nausea, or disorientation in VR, though the technology is improving. There are also concerns about potential eye strain from prolonged use, and just the practical safety of moving around physically while immersed in a virtual world.
You need to make sure you don't walk into a real wall while exploring virtual Rome.
Pretty much. And a really big one is data privacy and ethical concerns.
Because these systems are tracking everything.
They can track an incredible amount. Your movements, where you look, eye tracking, how quickly you react, your decision patterns, your mistakes.
Yeah.
This generates vast amounts of very personal behavioral data. So protecting that student data, being transparent about how it's collected and used, preventing misuse, ensuring algorithmic fairness so the AI doesn't perpetuate biases. These are critical ethical considerations that need strong regulations and safeguards.
Absolutely paramount.
And tied into that data is the challenge of assessing learning effectively.
How do you grade someone's performance in a complex simulation?
That's the question. Traditional tests, like multiple choice or essays, don't really capture the complex problem solving, the critical thinking on the fly, or the practical skills being demonstrated and learned in these environments. We need new assessment methods, new rubrics that are valid and reliable for this kind of learning.
Evaluating a different kind of competence.
Exactly. It requires rethinking how we measure success.
Okay, so we've seen the incredible potential, deeper learning, amazing experiences, wider access, and we've acknowledged the real hurdles: cost, content, training, health, privacy, assessment. Given all of that, What's the overall picture the source paints for the future? Where is this heading?
The source argues pretty strongly that this fusion of AI, VR, and AR isn't just a fad. It represents potentially the next great leap in educational technology. It's moving beyond being just a novelty, something cool we saw maybe 5 years ago.
It's becoming a serious tool for education.
A fundamental tool, potentially. Its core power lies in that shift we started with, transforming passive instruction into active, hands-on, experiential learning.
Providing experiences that were impossible before.
Or inaccessible, yeah. Letting students truly explore, experiment, fail safely, and interact within these dynamic, simulated worlds makes learning, theoretically, much deeper, more engaging, and longer lasting.
And for places with tech strengths, like Canada.
There's a real opportunity, the source suggests, to be a leader, to leverage existing strengths in AI, in game development, in education, to really shape and implement this future of learning, especially in those key areas like STEM, skilled trades, healthcare training.
But only if we tackle those challenges we just discussed.
Absolutely. Realizing the full vision isn't guaranteed. It requires deliberate strategic effort and investment to overcome the hurdles of cost, content creation, equitable access, and effective teacher training.
And it needs to be done thoughtfully.
Very thoughtfully. The source emphasizes a human-centered approach. The goal shouldn't be to replace reality or disconnect students from the physical world or human interaction.
It's about enhancing learning, not replacing teachers or classmates.
Exactly. It's about strategically using these powerful tools to enhance our ability to understand the world, to practice complex skills, and to engage with challenging concepts in new ways.
So the ultimate vision is what? Breaking down classroom walls.
In a sense, yeah. Breaking down the traditional limitations of the classroom physical, geographical, safety, cost to provide richer, more diverse, more effective learning experiences, equipping students with the adaptable skills and deep understanding needed for a future that's only getting more complex.
And AI is the key ingredient to making those immersive environments truly powerful for that goal.
That's the core argument. Leveraging AI thoughtfully within VR and AR is how we unlock that transformative potential.
Wow. Well, this has been a really comprehensive deep dive into a fascinating area. Thanks for joining us today to unpack all of this.
My pleasure. It's definitely a space to watch. It's moving so fast.
Yeah, absolutely. So just to recap for everyone listening, we've journeyed from the limits of traditional passive learning to the potential of these dynamic interactive experiences powered by AI, VR, and AR.
We looked at how AI specifically makes these environments tick, generating content, powering characters, personalizing the experience, giving real-time feedback.
Right. We explored applications from virtual time travel to safe virtual labs to practicing surgery and even soft skills. We highlighted the huge benefits: engagement, retention, safety, access.
But also grappled with those very real challenges: the cost, the complexity of content, the need for training, and those crucial ethical questions around privacy and assessment.
It really underscores that the technology is only part of the equation. How we implement it, how we make it accessible and use it ethically, that's just as important.
Couldn't agree more.
Which leads us to a final thought, something for you to maybe mull over after this deep dive. We've talked a lot about the potential for this technology to democratize access, to bring experiences to those who couldn't reach them before. But we also talked about the high costs of hardware, the resources needed for content, the digital divide. So here's the question. Given those challenges, how do we, as a society, ensure that the incredible potential of AI-powered immersive learning doesn't end up widening the gap between the haves and have-nots? How do we actively work to make sure it becomes a tool that genuinely bridges that divide for learners everywhere?
That's a critical question. Definitely something to keep thinking about.
Indeed. Thank you again, everyone, for diving deep with us today on Tech, AI, and Beyond. We hope you found this exploration valuable.
Yeah, thanks for listening. Keep exploring, keep asking questions about how this tech is changing things.